Hi everyone, can you hear me? Just let me know if audio, video, everything is fine, and then we will start. Okay, so just confirm if you can hear me and audio, video, everything is going good. Okay, so once you confirm me, I will just start. Okay. So let's get started. So today we will see, more questions, specifically, question number after question number 50. Okay. So this session is going to be very interesting. The reason behind this is because we are going to solve, I can say most trickiest question or most interesting question of AIMT2. There has been, few questions which were interesting and those were 2 marks. So today we will solve 2 marks question, right? More of 2 mark question. So let's just get started and let's just see that how to solve all of those questions. Okay. So let's start with this question number 50. Right. So in this question number 50, they are saying that they have given some linked list. This is 2, 4, 6, 8, 10. Okay. And then null. So they are basically having a function which is not just a normal function. This is a recursive function in nature, right? And I've named it like recursive swap. Okay. The name of the function is recursive swap. This is doing something. Now see, linked list. Okay. Linked list and recursion. Okay, I can say this is a little, a little dangerous combination. Okay, if you are having recursion on the linked list, then you should be little bit more careful than the usual linked list question or the usual recursion question, right? So let's just get started with this question and let's just see what this question is saying. By the way, how many of you are Go classes complete course enrolled students? Because in the complete course we have already seen these kind of questions where I have dealt with linked list and recursion very nicely. But even if you are not complete course student, don't worry, we will we will be solving this question in very best form or in very nice form today. Okay, so what they are saying is that you have a linked list which is looking something like this, right? And there is a function. Now let's just see this question very carefully. See, let's just take this function. Okay, let me just put this function on the side. Probably you can just see this. Okay, you are able to see the complete function, and then I will run this function on the given linked list. Okay, so this is the given linked list that we have here. Now let's just try to run this given function on this linked list. Okay, so what we are saying here is that let's see, you have this function which is recursive in nature, right? Now this function will be having, in this function you are having few variables. For example, you have head is one of the variable. Head this first is one of the variable, second is another variable, head is another variable. So few of the variables are there. These are, if you notice, these are like whatever variable I have, which is head, first and second. Okay, these are the variables which I have here. These are called local variable, right? Local variables. Okay, this is important. Okay, this is important to understand that these all are local variables. Okay, why that is important, you will get to understand. You will get to understand very shortly that why I'm saying that this is important to understand that these are local variables. See, now what will happen, that you will call this recursive step function with the head pointer, right? Now let me just partition this something like this. I will just explain that why what I'm doing here. Okay, so see here what I'm doing. I'm saying, okay, I'm saying that you are basically calling this function with this head. So currently head is a local variable and you are pointing this head to 2. Head is pointing to 2, and first will point, first is also a local variable which will start pointing to 2 because of this line, and then second will start pointing to head next. So second is also the local variable which will start pointing to whatever head next is pointing to. So second will start pointing to this. Are these three variables are okay to everyone? See, this head doesn't matter to me because head is anyway, head is doing whatever the first is doing, so whatever head is pointing to doesn't matter much. But yeah, is this okay that what this first is pointing and what the second is pointing? Because this is very important, right? Now you see what is happening here. Okay, just see carefully about this line. Okay, once the assignment is done, see, these two are very easy. These two are very easy lines, right? But once this assignment is done, now you just see here what is happening. We are saying first next. First next means this two next, right? See, first is pointing this, but first next is pointing to 4. So they are saying that first next, which means this 2, right? This 2, okay, will be pointing to, this 2 will be pointing to. whatever this function is returning. Okay, so basically I don't know. See, once this function call is happening, okay, I'm calling this function at 2, and now once this function call is happening, I don't know that what this function is returning. So I'm waiting here. Okay, this is like a wait state, like 2 will be pointing to whatever this function is returning, right? And then I'm calling this function with a recursive swap function. So I can say if I just write this little neatly, I can say that this 2 will be pointing to whatever this function is returning, right? This recursive, okay, swap function, whatever this returns to, this 2 will be pointing to that, right? This is important to understand. Now just see here, the second next will be pointing to first, right? Second next means this is second next means this, right? I mean 4 next. So 4 next, this particular pointer will be pointing to first, right? Which means it will be pointing to 2. See, whatever this recursive swap return, right? Whatever this line return, it doesn't matter to me in the sense that, see here, this line is basically calling from second next, right? It is basically calling second next means this particular point, right? I mean, this is the second next. So this line, this line is basically calling to the second next, right? This next, which means I'm next calling on this particular node, right? I mean, see, initially I started calling on 2. Now I will be next calling on 6. Okay, so initially 2 was called, I mean head was 2 basically. Now head was 6 for the next recursive call. So what I'm trying to say here is that this particular call is for 6, right? This particular call, the initial call was for 2, but now this particular call is for 6. So initial call is for 2, now next call is for 6. Now why I'm again and again emphasizing is that that next call is for 6 means that whatever this function is doing, right, this function cannot change first, which means at this point in time, see, at this point in time, first is pointing to 2, and after the recursive call also, okay, whatever you do in the recursive call, first will also be pointing to 2. See what I'm trying to say, that you just understand this carefully. Okay, for example, see, if I consider these are two lines, 2 places, let's suppose place number 1 and place number 2. Okay, these are, let's suppose, 2 places, right? So at this place, first is pointing, at place number 1, first is pointing to this. Now at the place number 2, place number 2 means I am in this particular call only. Whatever this return, let's suppose everything is done, I mean this has returned whatever it has done to this particular particular linked list. So this 2 4 will be at least intact, right? See, this 2 4 will be at least intact because I'm next calling on 6, right? This is the next calling on 6. So at least until, I mean, this particular call cannot change this link 2 to 4, right? So whatever this returns, right, it doesn't matter to me. First, if first is pointing to this 2 at this point in time, if first is pointing to 2 at this point in time, then at the place of second, okay, at the second point, first will still be pointing to 2, right? So what I'm saying, the second next is first. So second next, which means 4 will start pointing to first, whatever first is pointing to. So this line will make sure that 4 is started pointing to whatever this first is pointing to, right? So see, what I'm saying here is that, let me just summarize everything. Okay, I mean, I will go step by step, but for now, let me just tell you that what I'm trying to say. What I'm saying, that you are making some call. Okay, you are initially starting with 2, right? That is for sure. You're initially starting with 2, which means head is pointing to 2. Now first is also pointing to 2, right? I mean, these are the local variables. This is one activation record. I mean, you don't need to worry about the activation record and these things, but yes, this is one activation record, and second is pointing to 4, right? So this is the initial activation record, like you started with this activation record. Now the next activation record is at 6. Basically you will say that next you will be calling with 6, right? I mean, let me probably make like this. Okay, so this activation record here, head will be pointing to 6. We will come to that. I mean, I will just tell you that what it is happening. First will also be pointing to 6, and the second will be pointing to, at the next call, second will be pointing to 8 actually, right? This will be the next call basically, right? But in this call, head is pointing to 2, first is pointing to 2. Actually head doesn't matter because head is anyway not used, right? Head is not, we will be using first, so head will not be used anymore if we are using first. But yeah, I'm just telling you that, okay, you are basically calling with head, so that's why I'm telling you. But yeah, first will be pointing to, in the next recursive call, first will be pointing to 6 and second will be pointing to 8, right? But in the very first recursive call, first is pointing here, second is pointing here. Now this is one line, okay, which is the recursive call line. This is interesting line, right? This is very interesting line, which is the recursive call line. Let me just copy this line on the next page, and then I will just tell you that what this line is doing, right? So this line is very interesting line. See, this line is saying that first next, okay, so initially first and second are pointing something like this, right? Now this line will be called, okay, that's okay. But what I'm saying, after this line also first will still be pointing to this, right? I mean, this line cannot change whatever first is pointing to, because this line will be starting from 6. I mean, this line will be basically taking 6, 6 head, right? This line will be basically doing something like this. So first will still be pointing to 2. So basically first is not changed using this line. So after this line, if I'm writing something like this, right? After this line, let's suppose if I'm writing something like this, which is second next equal to first, right? Second next equal to first. After this line, if I'm writing something like this, it means what? It means that after this recursive call, second next means 4, right? This 4, 4 next, 4 will be pointing to 2. So basically what is happening, first next, which means that whatever 2 is pointing to, I don't know. I mean, first next is actually holding, right? This is the recursive call, right? So whatever 2 will point after the recursive call, I don't know. I mean, I'm still in waiting. But 4 will start pointing to, okay? 4 will start pointing to 2. So basically in the final answer, 4 should start pointing to 2. And whatever 2 is pointing, let's just see. I mean, whatever this will return. Let's suppose this is returning pointer to 8. Or this is returning pointer to 10. Then 2 will start pointing to 10. If this is returning pointer to 8, then 2 will start pointing to 8. Right? So let's suppose in this recursive call, whatever I do, I will just check. Let's suppose in this recursive call, I'm just returning pointer to 6. Then 2 will start pointing to 6. See, if I'm returning 6 from this, then 2 will start pointing to 6, 4 will start pointing to 2. This will be some partial linked list. If I'm returning 6 from this, so it will depend that what 2 is pointing, it will depend on this recursive call, right? This recursive call will determine that, okay, what this particular 2 will point to, right? 2 might point to 6, 2 might point to 8, 2 might point to 10. It will depend on this particular recursive call. Is this clear to everyone or not? Because this is very important to understand that whatever this is returning, 2 will point to 2 will be pointing to this, and 4 will be definitely pointing to 2 because of this line. Okay, so finally my answer should contain 4 will be pointing to 2, and whatever the second recursive call, which is this, okay, whatever this is returning, right, my answer will depend on that, which means, let me just write it. Okay, see, something like this, right? So is this clear to everyone? That let me just check that what this particular recursive call is returning. But yes, in the final answer, 4 will be pointing to 2 and 2 will be pointing to something that I still don't know. I mean, that is in the mystery, right? I will just solve it. Okay, I will solve that mystery. But final answer should contain 4 will be pointing to 2 and 2 will be pointing to something. So maybe with the options, let's just check. Okay, so in the final answer, 2 should point to 4. I don't know, maybe 2 will be pointing to 4, but I mean, I don't know what 2 is pointing, right? But I know that 4 will be pointing to 2 for sure. So 4 should point to 2. In the final answer, 4 should point to 2. So that is why either B is answer or D is answer, right? Either B is answer or D is answer. So either B is answer or D is answer. So let's just check which one is answer. So either B or D. Is this okay to everyone? Because this is very important to understand that either B is answer or D is answer. Right? Now let's just see that which one is the answer. Okay, so 4 will be pointing to 2. Why? Because of this line. Okay, because second next, which is 4, will be pointing to first, and first can't change because of this line. So, and 2 will be pointing to something which this particular recursive call is returning. So basically, okay, I am in this recursive call. Let me just copy this. Okay, so particularly, let me just now it will be smooth for you. Okay, now I think you will just understand this very nicely. Okay, so let's just start again. Let's just see what it is doing, right? So initially first is pointing to 2, right, and second is pointing to 4. Now there will be some recursive call which is saying first next. Okay, which is saying first next. Maybe I can just copy that particular line directly. Okay, so that I can easily paste it. Okay, so now these are the two lines, right? So first next will be pointing to something, which means first next means whatever 2 is pointing to. But because of the second line, I'm sure that, okay, 4 will be pointing to 2. So 4 will be pointing to 2, and then I'm still waiting that what 2 will be pointing to. So anyway, let's just do step by step. Let's just see what this recursive call is doing. Okay, so basically currently first is pointing here, 2 is pointing here, and then ultimately 2 2 is waiting. So 2 first next means 2, right? So 2 is waiting to point to something. Okay, whatever this function call return, then 2 will point to that, and then because of this line 4 will point to 2. Okay, so let's just see that what this function call is doing. I am calling this on second next. Second next means this is basically second is pointing to this. Second next means this particular point, right? I mean the address of this particular node. Okay, so second next is basically this, which means I will be having, now the recursive call will be having head, which will be pointing to 6, and whatever head is pointing to, first will point to the same thing. First will be pointing to 6. Now second will be pointing to 8. Is this fine to everyone? Okay, now these recursive calls are important to understand. Is this fine to everyone? Now let's just see what is happening next, right? Now what will happen next? Now see this particular first, okay, I mean this 6 will be again waiting for whatever my recursive call is returning, and second will anyway point to 6, and 6 is basically waiting for whatever my recursive call is returning, right? So here 2 is, see 4 will point to 2, and 2 is waiting for whatever this recursive call is returning, and here 8 will be pointing to 6, and now 6 is waiting for whatever this recursive call is returning. I mean this actually happens little later. I mean once this recursive call return, then only 4 will point to 2, but just for the sake of understanding I'm telling you that okay, 4 will point to 2 and 2 will wait for whatever recursive call is returning. Here 8 is pointing to 6 and 6 will wait for whatever recursive call is returning. Now recursive call says second next, so second is pointing to this. Now second next is actually 10, right? So I will be now calling with the head, which is 10, right? Now head is now 10, which means first is 10, right? And which means second is null, right? And in the recursive call, base condition says the head is null or head next null, which means either there is no node in the linked list. Head null means what? There is no node, linked list is empty. Head next null means what? The linked list has just one element, right? So if linked list has just one element, which means if I'm calling to 10, right, then it will return head directly, right? It will return head directly. So this is the first recursive call that will return. So I will be calling on 10, and 10 will return. Still 10 will return what? Head itself, which means 10 itself. Now interestingly, who is waiting for this return? This, right? So this 6 will be pointing to 10. Is this okay to everyone? Because this is important. 6 will be pointing to whatever this function call will return, but this function call will directly return 10. Okay, so 6 will be returning 10, right? Now 8 6, so basically 6 will return 10, and because of the next line, because of this line, 8 will start pointing to 6. So 8 6 10 is there. Now let's just see what this function call is returning. Okay, now if this is base case, then it will return head, that was 10. But if it is not base case, it will return second. Okay, so second is what? Second here in this particular, in this particular function call, second is basically 8. So it will return this 8 6 10 link will get established, and then it will return 8. And who is waiting for 8? 2 is waiting for 8. So 2 will start pointing to 8, who is pointing to 6, who is pointing to 10, and then because of the last line, this 4 will start pointing to 2, right? And now we are returning second. Second means we are returning the pointer to 4. So now we are returning the pointer to 4. So finally we are returning this particular pointer. So 4 to 8 6 10 should be the answer, right? So 4 to 8 6 10. So I think B is the correct answer. This is very interesting question. How many of you have understood this question? How many of you have understood this question? Let me know. Okay, understood, right? Great. Now let's just move to the next question. This was a very interesting question. If you want, I can quickly repeat it. Okay, if you want, I can very quickly repeat it, that what it is trying to say. Okay, in just 1 second I can repeat it. See, my linked list is 2 4 6 8 10 null, right? My linked list is this. Okay, now if you are calling, okay, first will be pointing to this, and second will be pointing to 4. Okay, if you are calling something like this, now 2 will be waiting for, okay, that what this function call will return. Now this function call will say that okay, first will be pointing to this, second will be pointing to 8, right? Now 6 will be waiting for whatever this function call will return. Now next function call is at 10, so first will be pointing to 10, second will be pointing to null, but this will return 10, right? The first thing that it will return is 10. So now this will get 10, right? So 6 will start pointing to 10. Now because of the next line 8 will start pointing to 6. So 8 6 10, and now it will return 8, right? It will return 8. So 2 will start pointing to 8, and then 6, and then 10, and because of the next line 4 will start pointing to 2, which is 2 8 6 10, right? Something like this. So that will be your final answer. Understood? Okay. Okay, thank you so much. So this was the answer, right? Now let's just move to the next question. Okay, so let's just see that what this is saying. Okay, so this is the question number 51. This is question number 51. This question was really easy question, I can say. Okay, if we are having doubt, then we will just clear it out, but this was easy question. What this pointer of this question is saying, this is saying that pi1, okay, pi1 is basically pointing to malloc 2 into size of int, which means this will be pointing to some two integers, right? It will be pointing to the space of two integers. And pi2 is basically pointing to, I mean, it will be pointing to the first integer, and pi2 will be pointing to the second integer. I equal to 1 is there, okay, and free of pi1. So basically they are saying that you completely free it up. It means that this particular memory is free to use. Okay, this particular whole memory, okay, whatever pi1 completely pointing to, it doesn't mean that okay, it is pointing to just one element, it will just free this up. No. Whatever you have allocated using malloc, it will free up the complete memory. So this complete memory will get freed up, right? And now you are saying pi2 minus 1. So basically you are now again here, okay, pi2 minus 1, which means you are again here, and now you are saying okay, you just dereference it, which is illegal. Okay, I mean, you can't do it. Okay, this particular point is basically dangling pointer. Is this okay to everyone or not? Right? Okay. So this is dangling pointer, and now pi2 equal to null. So pi2 equal to null means what? That I mean, actually it doesn't really matter whether pi2 equal to null or not, but this is a dangerous thing, right? So you can't dereference on pi2 minus 1 or something like this. I mean, you can't neither dereference on pi2 directly, nor you can dereference on pi2 minus 1 or something like this, right? So you can't do these kind of things because this memory is completely freed up. Okay. So that's why dangling pointer, but there is no memory leak because since it has already been freed up, right? Okay, great. Now let's see this question. This question was a nice question, I will say, and one of the gate PYQ, I think one or two three gate PYQs are there, okay, which are using these kind of things, which means the signed and unsigned comparison. And we have very well covered. So for the Go classes students, and if anyone here is Go classes student, then just let me know, because they can just tell you that this has been very well covered in the class. Okay, I mean, signed and unsigned things, right? These things has been very well covered. Okay, so let me also tell you that there was one gate PYQ. Let me take the screenshot of that. Okay, and let me just paste it here. Right. So basically here, as you can see, that this is unsigned and these things have been used, and this is gate 2017 PYQ, and there has been 2-3 such PYQs, right? And these concepts are very easy. See, it looks, the good thing about these concepts is it looks scary because no one teaches it. Okay, looks scary just because no one teaches it, but once you get to know, you will see that, oh, that's so easy. This is so easy concept. Okay, but it looks scary because no one teaches it. But yeah, at Go classes we have taught these concepts very well, right? So let's just see what they are saying. See, they are saying that they want to compare these things, right? Actually here I have given you the hint that okay, if you are putting U, then it means unsigned, but they do not need to put this hint. Okay, they do not need to put this hint. This is just a hint that I have given. Okay, in the original question they might not put this hint. This is just a hint. I mean, this is a standard thing that if you put U here, then it is unsigned. Okay, but anyway, let's just check that how to do this question, right? So let's just go on the next page and let's just check how to do this question, right? Okay. Yes, even in the test series, there was a question something like this, right? So they are saying -1 is greater than -2. So let's just check. whether -1 is greater than -2. I mean, this is a normal comparison. So this is, let's suppose 0, this is 1, okay, this is 2, right? This is 2, this is -1, and this will be -2, right? So this is definitely increasing. I mean, this is a normal comparison. Normal comparison. So -1 is definitely greater than -1, right? I mean, this is true. There is no harm in this. This is true. Now let's check the second thing, which is saying -1u. See, this is very, very interesting. Okay, that -1u is greater than -2. What does this mean? Let's just check. See, first of all, tell me how to represent -1, and then I will just tell you that how to treat it this unsigned number. So we will represent using 2's complement. You might know this, right? So once let me first write the normal binary of this, then 1's complement and then +1, right? So 1's complement will be all 1's and then 0, right? This will be 1's complement. And then +1 will be 1 1 1 1 1 1 1 and then 1. So this is 2's complement, right? Now here, this is the representation of -1 in memory. Okay, I mean, you write -1u or you don't write -1u, doesn't matter. But yes, this is how -1 looks in memory. How it looks? It looks like this. All the ones. Okay, so it looks like this. Now if you are saying -1u, it means treat this binary. What does this mean? Treat the above binary as unsigned number, right? As unsigned number. Treat above binary as unsigned number. This is what -1u means, right? So let's just check. Okay, so basically what they are doing, they are saying that, okay, treat this as unsigned number. Do you know what is this unsigned number? Okay, if you just treat this as a normal number, then what it will be? It will be 2 power 0 plus 2 power 1 plus 2 power as something like this, right? If this is, I mean, if these are, let's suppose 32 bits, then it will be, I mean, it will be a huge number, right? 2 power 0 plus 2 power 1 plus 2 power 31, which will be 2 power 32 minus 1, something like this, right? But it will be a huge number. Let's not worry about the exact number, but if you treat it as unsigned number, then it will be a huge number. So basically -1 in memory is like this only. Okay, is like this only. Okay, you are doing -1 greater than -2, then also -1 is this. You are doing -1 greater than -3, then also -1 is this. You are doing -1 is greater than 0. I mean, whatever comparison you do, then also -1 is this, right? I mean, depending on the comparison, -1 cannot change. -1 is this only. But if you are doing -1u, it means that they are just telling you that how to treat this binary. Okay, if they are not telling how to treat this binary, then you will treat in the usual way. I mean, the way it is represented. So it was represented as a signed number, so you represent as a signed number. But if you're doing -1u, it means treat this binary as unsigned number. So if you treat this binary as unsigned number, it will be a huge number. So now they're comparing -1u in the option B, right? They're comparing -1u and -2. So they're comparing these two things, right? So they're comparing these two things. So let me just tell you that what will happen. So if we are going to compare, right, these two things, -1 and -1u. So -1u means that all ones are there, and now you treat it as unsigned number. This is a huge number. -1u means it is actually 2 power 32 minus 1, right? So basically it is a huge number, and obviously it is greater than -2, right? So this is true. Actually, I will just tell you that this -2 will also be treated as unsigned, but doesn't matter. Reason being is that this is the maximum number that can represent in the binary. Okay, for the unsigned, this is the maximum unsigned number. Right? So -1u is greater than -2. I will actually come back to this option B in just a while, but for now I'm just saying it is true. I will give more explanation about the option B in a while. Okay, but yeah, this is the maximum number in the unsigned number. That is why it is greater than -2. Okay, so I will come back to the explanation of B again. Okay, because I want to first explain C. Okay, see, in C we are saying C is very interesting. In C we are saying -1u, right? In C we are saying -1u is -1 is greater than 0u. It means treat this 0 as unsigned number. See, 0 representation in binary is just like this. Okay, 0 in binary is like this only. I mean, 0 in memory. looks like this only. This is the pattern of 0. I mean, there is no one who can change this pattern, right? 0 looks like this in memory only. Now what they are saying is that they are saying here is that you treat this as unsigned number. Now interestingly, if you are writing u here, okay, if you are writing u here, then automatically if you are treating one of the number in the comparison as unsigned, then automatically this will also be treated as unsigned. I mean -1 is greater than 0u is same as saying -1u is greater than 0u. Okay, is same as saying -1u is greater than 0. Okay, so these three are same. I mean, if we are putting u at one place, then automatically this u is at another place, which means -1u greater than 0, -1 greater than 0u. These two and these three, you can say these two are same as putting the u at both the places. Okay, putting u at both the places. I mean, these three are same actually. These three are same. Okay, this is important to understand. You put u here or you put u here, doesn't matter, automatically u will be here. I mean, you can't have the you can't have one expression where you will be having one of them unsigned and another one is signed. See, you know the promotions, right? I mean, if it is 3.0 plus 5, what it will be? Will it be 8 or it will be 8.0? It will be 8.0, right? I mean, it will automatically be float, right? Automatically be promoted to float. Automatically float. Is this known to you guys? If 3.1 plus 5, is this 8 or 8.1? This is 8.1, not 8, right? Not 8. Why? Because we are promoting this to float, right? So it will automatically float. Okay. Now similarly, if you are having one as unsigned, okay. So let me just tell you, I think we have covered these things in the class actually. In Go classes, I've taken, see, this is a screenshot from the class. So if you have one of them is unsigned, right? Sorry, one of them is int means this is signed int. So one of them is signed and another one is unsigned. So it will be promoted to the next. See, for example, if one of them is int, another one is float, then automatically both are float, right? If one of them is int, another one is double, automatically both are double. Similarly, if one of them is just normal int and another one is unsigned int, then both are unsigned int only. Is this clear to everyone or not? Let me know. Is this clear? Right? Because this is very important to understand. Okay. So now you just see here that here, even if you're writing -1u, -1 is greater than 0u, it means that this is -1u is greater than 0u. So -1u is actually unsigned number, unsigned ones, right? And this is all zeros. So obviously this is 2 power 32. This is basically comparing 2 power 32 -1 and 0 is greater than 0. Yes, obviously, right? This is unsigned comparison. Then obviously C is true. What about D? This is just a normal comparison which is saying -1 is greater than 0. What do you think? Obviously -1, there is no u here. See, A and B are very easy. Okay, so here A and B are very easy, right? Let me just tell you. You may be a little bit confused between C and D, B and C, but A and B should be easy for you guys, right? Okay, so here A is saying this is a normal thing, this is a normal thing, right? So these are normal to verify that yes, this is true and this is false. This is very normal, right? This is very normal. The only confusion could be in B and C. Now B is saying -1u. This is unsigned, maximum unsigned number. Now tell me, is this -2 or this is also unsigned? See, this is also unsigned, right? Actually, it doesn't matter because this is a maximum unsigned number. But yeah, this is also unsigned. So what is the actual value of this? See, 2 is actually this, right? 2 is actually this. You represent in the 2's complement. 1, 1, 1, 1, 1, then 0, all the ones, right? And then 0, and then this will be 1. Then if you just add +1, then it will be 1, 1, 1, 1, 1, 1, 1, 1, and then 1 and 0, right? So it will be 2. So it is actually lesser than all the ones, obviously, right? All the ones is 2 power 32 -1. This seems to be 2 power 32 -1, and then there is one less, right? -2 basically, right? So it is one lesser, right? This -2 is anyway one lesser. I mean, even though you treat it as unsigned, doesn't matter because -1u is the maximum unsigned number. Okay, so I told you that I will come back to this B. So I was just saying that okay, this -2 will also be unsigned, treated as unsigned, right? But this is maximum unsigned, so it doesn't matter. And similarly, -1, again, this -1 is maximum unsigned number. So -1u is anyway greater than any unsigned number, right? See, -1 u is anyway greater than any unsigned number or any actually number, okay, any number in the system, because if you are representing all the ones, then it is maximum unsigned number. Even if a signed number actually cannot overtake this. So minus 1 u is actually greater than any number here. So if you are writing minus 1 u, you can write anything here, it will be true only, anything here, okay, then it is true only. Is this okay to everyone? Tell me. Yes. Very happy New Year. So okay. Ankit is saying Happy New Year. So yeah, thank you so much, Ankit. Very happy New Year. Okay, great. Now let's just move to the next question, I think. Okay. Yeah, this question was again quite interesting, and I think in the key we have given five as an answer, but I re-evaluated it, and I think one should be the answer. Okay, so one is answer here. Let's just see that how to solve this question. Okay, what they are saying, that you have a recursive descent parser. See, again, these kind of things are less known to the to most of the aspirants, because they do not study this recursive descent parser and these things, right? And neither like many of the teacher teaches it. Okay, but gate can definitely ask these kind of questions, right? So recursive descent parser, by the way, we have one video. I will just strongly suggest you to watch that video. Probably I can just suggest you the video link here. What was the link? Just a second. Yes. So let me just paste that screenshot. Okay. So by the way, I will strongly suggest you to watch this particular video to solve these kind of questions, right? And these kind of questions could appear in other AIMTs also. So I will strongly suggest you that if you really want to understand recursive descent parser, you must watch this video. Okay, for recursive descent parser, this is my strong suggestion. Okay, if you want to study recursive descent parser nicely. Okay, now let's just see this particular grammar is given. Now let's just see that what is happening. Okay, now see here that what we will do, we will basically we want to basically parse this particular string, which is id, which is basically id, and that is in one bracket, and there's another id which is in two brackets. Okay, okay, so now you will be having e, you will be first calling c, you will be first calling id, right? Now listen carefully. You will be first calling id. Is id matching to this particular bracket? No. So it will be fail, right? So since this is fail, you will be backtracking on e. Okay, you will backtrack on e, right? So since you are backtracking on e, it means you will be again calling a different basically function, or the different production of e. So now this and this will match. So you will say, okay, this is good. Now you will proceed further, and this e, right? This e is basically you will be calling again. Now you will be calling. See here, you will be calling with id, right? Because this is the very first production. So in the recursive descent parser, the order of the production also matters a lot. So you will be calling with the id. See, this has already matched. Now id and id will be matched, right? And then this will be matching. So see here, what is happening here? Let me just tell you step by step that you will be matching this id with this id, right? And then you will say this is success. Okay, you will say this is success. So there is no backtracking happening at this particular node, right? So you will not backtrack on this. Now you will be basically comparing. You will say, okay, that is done, right? This is done. This is very important to understand, that there is no backtracking here. Now you will say, okay, this is also matching. Now it will also say it is success, because this particular thing has been success, right? Since this is also success, I mean this particular e is also success. Now your main function will be there. Here you are calling e. If this is success, right, and then you will match with dollar, right? You will match with dollar, and now this dollar is not matching with this, right? This dollar will be not matching to this. You will say ultimately you're rejecting. So recursive descent parser, descent parser will not recognize this string. Okay, will not recognize this string. It will do one backtrack, okay, it will say that okay, that you are getting this, and then since it is success on this E, so it will say okay, and then it will be success on this E also, it will say okay. See what is happening here, that you are having this particular grammar and you want to match with this, right? You want to basically parse this string id this, right? See what could have been ideal tree. Let me write ideal tree. What could have been the best tree or the ideal tree? See, you should be basically having, you should be going to this ee, right? I mean, see, this should be something like this, right? E, first E should produce something like this, right? So first E should produce the id. First E should produce id. Okay, this should produce id. I mean this one like this, and then this will produce bracket bracket id. So bracket bracket id means, I think, yeah, you should go to this. This E should be going to something like this, right? And then this E should again be going to something like this, and then this E should be going to id, right? And then this E should be going to id. Is this understood to you all? This is basically ideal tree, right? Okay, so this is what it should do. I mean, ideally this should happen, but is this really happening? Let's just see. Okay, let's just again see, is this really happening? This is what it should happen ideally, right? But is this really happening? Tell me. Yes, similar kind of questions were also in the class, right? Similar kind of questions were also in the class, right? So someone is saying टेस्ट सीरीज में भी एक ऐसा था. हाँ, टेस्ट सीरीज में yes, probably okay, maybe I have put this question, I don't exactly remember, okay, but probably I have put this kind of question, okay, in the test series also. Yes, we definitely did in the class, and definitely see, we also solve in the class, in the sense, actually in this lecture, right? In this lecture we solve Ullmann question also, okay, we solve Ullmann question also. In this lecture we solve actually many other questions in this particular lecture. So this particular lecture is must watch for this particular topic, okay? For this topic, this lecture is must watch, right? Now let's just see that what is happening here, okay, in this particular question. Let's just see this again. Now basically this is ideal tree. Now what is the problem that we are getting here? See, this E will be calling to, first E will be calling to id. Now you will say that okay, id is not matching, that is why there is a backtrack here. Let me just write bt, and then this id will be basically, okay, doing I mean, you will be calling with the next protection, right? Now you will be having this. Now basically what is happening, this should be failure. I mean, this should say fail, right? But I mean, ideally you should be calling with e, but you will not be getting the chance to call e. You will say okay, this is pass, I mean this is matching. This e will be first calling to id, right? You will say this is matching, and then this is matching. Since all of this is matching, that is why you will say, see, you will say first, you will say it is success, and now you will say this is also success, right? This is also success. So you will say wow, this is success. So you will return true, right? And now there's a main function. In the main function you will be writing e, and then you will be writing match dollar. Now this match dollar will not be matching, right? This dollar will not be matching with the next symbol. That is why you will say it is basically rejecting, okay? It will reject. So recursive descent parser with backtracking will do what? It will do one backtrack and reject the string. Okay, is this fine to everyone? It will do one backtrack and reject the string, right? So that's very interesting and very nice question. Okay, now let's just do the next question. Again, this question was also very nice. How many of you were able to solve this question? How many of you were able to solve this question? In this question they are saying, this question again, I will see, if you are not go classes student, that is why I'm telling you, in case if you are not go classes student, I'm telling you to clear your concept very nicely, okay? So I will just suggest you one YouTube video that I have taken a lecture. So let me just suggest that video so that you can solve this question, right? I mean, I will be anyway explaining, but still I will be suggesting you that particular video. Let me just take the screenshot. Let me just bring. Okay, So there are actually, I think, two videos. Okay, so you can search with these videos. You can basically, I will just put the screenshot. Okay, so what you can do, you can basically search with these names. Okay, you will be getting those videos. So one has got 14k views, one has got 6.7k views. So you just search for these two videos, and then you will get to understand this question very, very nicely. Okay. Yes. So someone is saying I have solved it. So yes, this question was nice. So let's just see. Let's just see what this question is saying. See, by the way, this question was exact same replica. I have taken this question from one of the standard university, but this question was exact same replica of one of the gate previous year question. So if you are able to solve this question, let me just tell you. See, if you are able to solve this question, then this AIMT question was exact same. So I will strongly suggest you to solve this question. This question has got 329 upvotes in just one question, 85,000 views. Okay, views on this question. So this question is GATE 2008 question. I strongly suggest you to solve this question. Once you solve this question is as it is. The question I have given in AIMT, it is from standard university, but it is as it is. Okay, this is as it is as GATE 2008. Okay, it is as it is as GATE 2008 question. So that is why I'm suggesting you to solve this question first, right? Okay. Now let's just solve this AIMT question. So what they are saying, you are having, okay, this memory division of virtual address, right? Okay. So you can watch these two videos, by the way. But yes, okay, let's just see here. So you are having memory division of virtual address division, something like this. First, tell me, what does this 10-bit mean? It means what? That, see, there will be chunks, right? So there will be one chunk here. Number of chunks we will decide, but yes, there will be one chunk here which will be having 2 power 10 entries, right? This will be having 2 power 10 entries. This will be having 2 power 8 entries, right? So basically this is having 2 power 10 entries. This will be having 2 power 8 entries, right? So these are 2 power 8 entries. This will be having 2 power 6 entries. This will be having 2 power 8 entries. And at the last level, actually this entry is just a byte. Okay, so you can say 2 power 8 byte also, but yeah, that's fine. Okay, 8 bytes. At the last level, you will be anyway storing the actual data, right? The process. So basically what is happening here, that one of this entry will be pointing to one of this 2 power 8 entries. This will be pointing to this particular chunk, whole chunk, right? So basically, the offset will be decided by this 8 bits and all. But yes, this will be pointing to one of this chunk. This will be pointing to another chunk of 2 power 8 entries, right? Another chunk of 2 power 8 entries, and so on. This will be pointing to one of the chunk of 2 power 6 entries. This will be pointing to another chunk of 2 power 6 entries, and so on, right? So, so basically, let me just make the diagram little more clear. So see what will happen. This will point to another chunk of 2 power 8 entries. Okay. This will point to everyone here will be pointing to 2 power 6 entries, and so on, right? Now this particular, this particular address split is given to you. Now what they are saying is that what is the number of bits you will be storing here, right? See, first tell me what is the size of it. See, once you calculate the size of it, so it will be pointing to this. It will be basically having the address of this, right? Now tell me what is the size of this particular chunk. If the page table entry size is given to you, okay, what is the size of page table entry? Page table entry size is 4 bytes, right? 4 bytes is given to you. Now, which means 2 power 2 bytes. So if this is 2 power 2 bytes, then what is the size of this? This will be 2 power 10 bytes. In terms of the size, right? In terms of the entries is this. In terms of the bytes, the size is this. In terms of the entry size is this. In terms of the byte size is this, right? Similarly, 2 power 8 bytes here. In terms of the byte size, right? Here it will be, you will not be multiplying with 2 power 2, because anyway it is the byte only, right? Because the last it is a byte. So the size of this is 2 power 8 bytes, right? So basically what I'm saying here is that, let me just tell you that here you will be having number of chunks. Let's not worry about it, but yeah, whatever chunk you will be having, actually at the very first level you will be having 2 power you will be having just one chunk, so 2 power 10 entries. In terms of entries, I'm writing 2 power 10 entries. In terms of byte, if you want to write, you can write 2 power 12 bytes, right? You can write size either in terms of entries or in terms of bytes, doesn't matter, right? At this level the size is 2 power 8 entries. In terms of bytes, the size is 2 power 10 bytes. At this level, the size is 2 power 6 entries. In terms of bytes, it is 2 power 8 bytes. At this level, at the last level, the size is 2 power 8 entries. Interestingly, in terms of bytes also it is 2 power 8 bytes. You don't multiply at the last level. Is this fine to everyone? Okay. Once you understand this, then we can solve, okay, this particular question nicely. Is this fine, everyone? Now, see here that this is 2 power 8 bytes. So if you want to have the pointer, or if you want to basically point to this 2 power 8 bytes, see what is the physical address space? Physical address space size is given to you, which is 30 bits, right? 30 bits physical address space. Okay, so see, ultimately all of this will be stored in the physical address space only, right? In the physical memory only, right? All of this ultimately has to be stored in the physical memory only. So physical address space is given to you as 30 bits, right? So basically which means that if you are storing, so just assume, okay, or just think like this, that you will be storing all of, see, if you want to point to this, right? If you want to point to one of this, then just think like physical address space is divided like this, okay? In 2 power 10 bytes. So basically 10, and then what is remaining? 20. So basically you need 20 bits. You need 20 bits to store here. Basically what I'm saying, that if you want to store this 2 power 10 bytes, okay, one chunk of 2 power 10 bytes, see, ultimately physical address is of how many bytes? Physical address is of 2 power 30 bytes. Okay, now assume you want to store 2 power 10 bytes here, okay, 2 power 10 bytes of chunk, right? If you want to store 2 power 10 bytes of chunk here, now just assume that this whole thing is divided into 2 power 10, 2 power 10, 2 power 10, 2 power 10, so that you can basically align this with respect to the address. So basically you will say that, okay, this is divided into, this is divided, the physical address space is divided into 2 power 10, 2 power 10, 2 power 10 like this, okay, 2 power 10, 2 power 10, 2 power 10 like this, okay. See, a general misconception is that whatever is your page table size, okay, it will be divided into that only, but that's not true. Frame size, what is the frame size that is given to us? This is 2 power 8 bytes, right? General misconception is that if you have something like this, if you have your physical address, then you will always divide, okay, you will always divide this physical address into 2 power 8 only, okay. You will always divide into 2 power 8, 2 power 8, 2 power 8, okay. You will always divide into 2 power 8. It's not like this, okay. These are the logical divisions, okay. It's not like this. You will not always divide into 2 power 8, and this is actually one of the major misconception. Because of that, this gate question, okay, this particular gate question was not solved by many of the people. As you can see, these are the question has 329 upvotes, which is a huge number of upvotes, right? And if I just tell you, okay, if apart from the question, if I just tell you how many upvotes that the answer has got, then you will be just surprised. Let me just tell you. Okay, so answer, you can actually check the answer on this particular question. Okay, answer has got 338 upvotes. Okay, so answer has got 338 upvotes. So basically this question is very popular question in the entire memory management. Okay, and in this question I have actually commented, okay, there was one of my comment, that comment also got many upvotes. I commented long back. Okay, so this is one of my comment. Let me just tell you. Yeah, I commented long back, and this has actually got, just comment getting these many upvotes on the comment is actually huge thing. So comment has actually got 197 upvotes, and I've commented on 2016. Okay, this is a comment from 2016 when I was preparing for gate. Okay, this is, you can say, almost 7-8 years back comment, right? So this is 8 or 9 years back comment, I can say, right? So this is 8-9 years back comment. Okay. When I was preparing for GATE, I commented, and this comment has got 197 upvotes. So this is one of the very popular question in GATE entire industry. I mean, the GATE entire, memory management, I can say. Okay. So one of the major misconception is that you will divide the physical memory always in 2 power 8, 2 power 8, 2 power 8, right? But that's not the case. You will divide based on this. If you want to store this 2 power 10 bytes, then you will divide into 2 power 10, 2 power 10, 2 power 10. So that's why 20 bits will be needed to address this. So it will be storing 20 bits. Now similarly, you want to point to this. This is 2 power 8 bytes. So you will be dividing into 8, and then this will be remaining 22. So basically it will be storing 22 bits. Now you will be basically storing this 2 power 8 bytes. So again, you will be dividing into 8 and 22. So basically this will be storing 22. So 20, 22 and 22 is the final answer here. Okay. 20, 22 and 22 is final answer here. Okay. Let me know if you have understood or not. Okay. So 20, 22 and 22 is final answer. Right. Actually, for more, since this is just, a problem solving, I cannot, go through the 2 hours or 3 hours of explanation. So that's why I'm giving the link, right? I'm also telling you that from where to study. Okay. Just watch these 2 videos and you will be in love with memory management. You will get to understand the real crux of the memory management. Okay. So basically 20, 22, sorry. Yeah, this is the question, right? So what is the answer? Let me know. What is the answer that we are getting? C, right? So C is the correct answer here. Okay. Is this understood or there is any confusion here? Tell me. Now have you understood this question? Okay. Now let's just move to the next question, right? Now let's just move to the next question. Yeah, this was easy question. This was MSQ question, by the way. Now, what they're saying in this question, consider Unix-like a system which maintains the Unix inode. Each inode has 6 direct pointers. Okay, so they are saying that each inode has 6 direct pointers, right? So 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, these are the direct pointers. I mean, these are pointing to the files, right? Okay, now 6 direct pointers, and then you are having one single indirect pointer. So single indirect pointer means that this will be pointing to something which is having many pointers, right? I mean, this is itself having many pointers, right? So this is pointing to something, right? And then one doubly indirect pointer, which means this will be pointing to something, and then this is pointing to file, basically, right? Which will be pointing to many pointers. Okay, and then this will be again pointing to many pointers, and then this is pointing to finally file. Okay, so basically one doubly indirect pointer. Okay, this is singly indirect, and this is double indirect. Now they are saying the block pointer size is p bytes. So this block size is b bytes. So you can have p by b. Sorry, b by p, right? Block size is b bytes. So b by p number of pointers, right? B by p number of pointers here. Okay, so similarly b by p number of pointers here. Now what is being asked is that assume that file is already open, the buffer is simply disk operation needed single file. Okay, so they are asking how many disk operations are required to read from the data from the nth block file. Okay, so see, if you are just reading first file, I mean, if it is among the first 6 file, if n is less than equal to 6, then just one read. Is this okay to everyone? If n is just less than equal to 6, I mean, that is easy to understand, right? But if n is greater than 6, then you will be basically reading something like this. And then if it is accommodate, if your file is one of this, right? Which means if your file is something like this, if n is greater than equal to 6 and it is less than equal to b plus p. See, there are b by p, right? So there are b by p files that you will be pointing here. So if n is less than, greater than 6 and less than equal to b by p, 6 plus b by p, right? I mean, 6 plus will anyway there. So 6 plus b by p means among one of this file, right? Then 2 reads. Is this okay to everyone? And if n is greater than 6 plus b by p, which means if your file is one of this, right? I mean, your file is basically not among this. If your file is one of this, which means you will be going through like this, right? You will be having 2 access, right? Sorry, 3 access. So you will be having 3 reads. This is easy question, I guess. I hope most of you were able to do this question, right? Yes. Okay. So now let's just move to the next question. Okay, that was I guess easy question. So by the way, how many of you were able to solve this question? Okay, so one user is saying yes, who is Lord Ajay. So I've seen your comments, your answers in the Gate Overflow. You are doing really good work. Okay, so most probably you will be getting top rank based on your answers or based on your comments on the Gate Overflow. I can just assume, okay, or I can just see that your preparation is going very very good. So just keep it up. Okay, so it is just a motivational boost for you. You can just keep it up, and most probably you will be getting the top rank. Okay, I'm almost sure based on your comments and all, I can say that you will be getting very very nice rank. Okay, just keep it up. Okay, now let's just move to the next question. Yeah, so this question was also, I think, doable, easy question, I can say, right? So what they're saying, that select the correct semaphore initialization where you will be having hello is printed exactly once, right? So see here that in this particular case, you are having a equal to 1, b equal to 0, and c equal to 0, right? So you want to print h, e, l, l, o exactly once, right? So see here that you obviously have to start with h. I mean, first you have to print h, right? So you should be having b h 0 and c h 0, which is fine. I mean, which seems to be good, right? So you will be first going here because now the a will be 0, and then you will say h e will get printed, and then signal b, right? Signal b means you will be waiting for the signal, right? And then you will, sorry, signal b means that you will be enabling the signal, which means you will say that okay, now b is 1, right? Now b is 1, and then what you can do, you can basically do this, I mean, signal b again also, or you can just interrupt. So let me just first tell you, what if you interrupt, right? What if you interrupt? If you interrupt, because see, okay, I will just tell you, actually it should be mentioned in the question that is counting semaphore. Otherwise, if it is not counting semaphore, then this signal might get lost, and then none of the option will be correct. But yeah, I will just mention in the question. Okay, I mean, from the options it is inferred that it is counting semaphore, but yeah, I will mention in the question also. So by the way, now signal b has happened. Let's suppose you are interrupting, right? So wait b will get executed, and then you will I mean, wait c anyway can't get executed, right? So wait b will be executed, and then you will be printing l, and then signal c, right? So signal c means that c will be also 1, right? C will be 1. Now since c is 1, so basically what you can do, if you want, you can come to this, right? But you will not be bypassing this, right? Because here you need two waits. I mean, basically just because of one signal you can't do this, right? I mean, the c should be 2, then only you can print this 0, right? C should be 2, otherwise you can't print the 0. So having C1, just bypass one of this. I mean, if you want, you can interrupt and you can just wait here, or if you want, you don't interrupt, right? I mean, you can do anything, right? So you can maybe interrupt and you can wait here, okay? And then C is again 0. Okay, that's fine. Now you will be again signaling. Okay, you will be again, so b was actually 0 because of this wait. You will be again signaling on b, then b will be basically 1, right? So b will be 1, so you will be basically again printing l. Okay, and then again signal, so you will be basically now able to print o. Okay, HELLO. But what if, okay, let me just tell you, maybe I will just tell you, just a second, let me take again a screenshot, because that has got overwritten. Okay, so see here, that what if you are basically doing this. Suppose you are here, okay, a is 1, okay, let me write ABC here. A is 1, b is 0, and c is 0, right? Now wait a means that you will be basically making it 0, right? And then HE will get printed. Now signal b, and let's suppose 2 times signal b is happening, doesn't matter, you can do 2 times and it will be 2. First it will be 1 and then it will be 2, right? And then now you will say that okay, go to loop 1. Actually it won't do anything because it will be anyway waiting. So it is finished now. Okay, you can finish the process 1, okay, if you want to. Now this wait b will do what? See, you can't anyway do wait c, so you have to do wait b, and then it will print l, and then signal, it will be 1, right? It will be 1. Now if you want, you can interrupt, and then you can go here, and then it will be again 0, or if you want, you can just finish this process 2 also, right? Then again wait b, but you can't just happen this wait b, right? That is why, okay, b is already 2, so you can do it. Okay, so basically you will be doing this wait b, and then b will be 0, right? And then it will print l, and then you will be basically signaling, so c will be 2, and then you can basically, I mean, if you want, you can do wait C 2 times and then 0, right? Oh, sorry, O. So hello will get printed like this. So option is definitely printing hello. And interestingly, option A cannot print anything other than hello. Okay, so that's what they're saying. See, this is loop, right? This is loop. I mean, everything is loop. Okay, so this process are not just running one time. Everything is in loop. Now, what is the question saying? Hello is printed exactly once. Okay, hello should be printed exactly once. Now let's just see, can you print this twice? So the answer is no, because this is the starting point, wait is the starting point, and no one is signaling this, right? So you can't do this again. Once everything is 0, you can't just do this again. So even though you're looping, but it will be exactly printed once. Okay, even though you're looping. Okay, now let's see this B, option number B. I think that's easy question to verify, but still let me quickly verify this. Okay, so see, if both are 1, then definitely you can print this L, right? And then it will be a problematic situation, because if you print this L, then hello will not be printed exactly. I mean, maybe hello can be printed, but let's just see. Okay, maybe I can just tell you. See, wait A, right? You will be printing. Let's see if you even can print hello. Okay, first let's just see this. H E will get print, and then signal B. Signal B, if you want, you can do signal B. Or okay, this is just one signal. These are not two signals. Okay, so then wait B will be printing L, right? And then signal C, and then okay, you are doing wait B, and then probably you are doing signal C. Signal C means if you want, you can make it 1, and then you will be looping, right? But since so B will be 0, but since B is 0, you want to be able to loop it, but if you want, you can just execute this, and then B will be 1. So you are able to print, I think you are able to print hello, right? But apart from hello, there are other things that are also getting printed. I mean, there is chance that other things can also be printed, right? If you're directly starting from this, you can print other things also. Okay, and since this is MCQ, okay, actually in this question I will mention that hello should be printed exactly once. So by default it means that there should not be any other print other than hello, but I will mention this also, right, that there should not be any other print other than hello. Okay, so to print the word hello, execution may switch between the process. So actually this was easy question. Let me know if you have understood this question. Okay, yeah, this was nice question. This was very nice question. Okay, nice question. Let's just see how to solve this question. Actually, there's a common doubt that is happening in this question. I will just clarify all the doubts and all. Okay, so let's just see how to solve this question. So what they are saying in this question is something like this. Okay, so this was a nice question, so let's just try solving it. So they are saying that you are having 9 MSS file to send. Okay, so I mean, size of the file is given in the terms of the MSS, which is EG. I mean, EG in the sense which is convenient for you, right? So they are saying there are two versions. Okay, and in both the versions, 4th segment is actually getting lost. Okay, and they are detected by 3 duplicate ACKs. Indicate 3 duplicate ACKs means, see, they have also given the definition of 3 duplicate ACKs. So generally, let me just tell you one thing which is not relevant to this question, but still, okay. So generally in some universities, what they do, let's suppose this packet is lost, right? Now, if you do 1, 2, 3, 4 transmission after it, so one transmit, let's suppose this is packet number 4. This will say, okay, ACK4. I mean, since ACK4 was lost, this will say ACK4, this will say ACK4, 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 ACK4. So total, how many ACK4 will be received? How many ACK4 will be received? Tell me, because of these 4 packets. 4 AC, or let me write 8, 9, something like this, so that you will not be get confused with 4 and 4. How many ACK9 will be received? 4, right? Because of, let's suppose 4 packets you are sending after it, right? 4 ACK9s. So 4 ACK9 or 4 ACKs, they call it 3 duplicate ACK. I mean, one is the original ACK, something like this, and 3 duplicates. Some universities call like this. Some universities says that this is, let's suppose 9, which is getting lost. Okay, now if you are sending 3, okay, this 3 ACKs, okay, these 3 ACKs, they call it 3 duplicate ACK. Okay, but that has to be defined, because that depends on university to university, that depends on convention to convention, book to book. Okay, some books has 4 ack, they say that these are the 3 duplicate ack because one was the original one and 3 are the duplicate, and some people say okay, directly 3 duplicate. So basically they have defined, that's why they have defined in the question that okay, 3 duplicate ack indicate 3 segment has been reached out and one of the early segment is missing. Okay, which means 3 segments has been reached and one of the early segment is missing. So these are called 3 duplicate acks. Okay, 3 ack, these are 3 duplicate ack. Is this okay to everyone, this convention? Is this convention okay to everyone? Let me know. Okay, 3 duplicate ack means that one of the early segment is missing and then these of the 3 duplicates has been 3 duplicate ack has been arrived. Okay, anyway, now it was just convention, but let's just read this question. It is easy question, to be honest. Okay, so what they're saying, on receiving 3 duplicate acks, goes to so let's start with the following parameter. Okay, so if you are receiving 3 duplicate ACKs, one of the version says that okay, C and W equal to 2, I mean congestion window divided by 2, it will be the slow start threshold, and then you will be basically going to the congestion avoidance phase, or I mean let's not worry about the phase, or they have written the phase. Okay, so oh sorry, you will be going to the slow start phase if C, W and equal to 1. Okay, you will be going to the slow start phase, right? And then in the slow start phase, you start from 1, then 2, then 4, then till this C and W by 2, right? That is what you already know. And in the second version, they are saying that okay, slow start is actually congestion window by 2, and congestion window will be actually increasing by 1 once you receive 3 duplicate ACK, right? Now, actually I have the diagram directly, so maybe I can just show you the diagram. Okay, so see here, let me go step by step. Okay, this is the version 1, right? In the version 1, you will be sending first packet and then CW and equal to 1, then 2, then 4, something like this, right? I mean both the versions it is like this, right? So in 1, you will be receiving the ACK. Now you will be sending 2 packets, you will be receiving the ACK. Now you want to send 4 packets. So here you have sent 4 packets, but they are saying the packet number 4 is lost, right? So since packet number 4 is lost, so 5, 6, 7 you have already sent. Now interestingly, you just observe this here because this was the doubt of many students. Okay, so interestingly, 4, 5, 6, 7, right? So here you are saying this 4 is lost, right? Which is okay, but your current window, this is the selective repeat window, right? Sliding window. Okay, this is sliding window. Your current window says that okay, this is ticked, this is ticked, this is received. I mean, since you are having 4, 4, 4 3 times, that definitely means that 5, 6, 7 has been received. Then only you are getting 3 ACKs. Right, I mean 3 ACKs of 4, 4, 4 definitely indicates that these has been received. Now this is missing. Okay, this is missing. Now can your window slide? Tell me this. Okay, think about it and tell me, can your window slide? Let's suppose, what I mean to ask, let's suppose you are having 4 here, 5 here, 6 here, 7 here, 8 here, 9 here, 10 here. Okay, I mean you don't have 10 because you have just 9 MSS to send. Okay, so basically in this particular question, you are having something like this, right? I mean this is your current window. Now if this is lost, these 3 are received, can you slide this window? This is my question. Can you slide this window? No, right? Obviously you can't slide. I mean once you if the window size is 4, obviously if window size is 5, then probably you can just include this, but you cannot slide. I mean it cannot pass 4, right? Okay, currently window size is 4. Anyway, so basically now the 4, 5, 6, 7 has been sent, 4 is lost. So 4, 4, 4, these 3 duplicate ACK has been received. Now on the 3 duplicate ACK, it is given that okay, you will be basically setting the current window size as 1 in the version 1, and the slow start threshold is 2. I mean divided by 2, right? Now which means window size is 1. If the window size is 1, obviously you will be sending 4. Once this 4 is also received, then obviously you will not be sending 5, 6, 7, right? You will be sending directly 8 because these has been received, right? This is very interesting question. Okay, see earlier in the questions they directly ask okay, so what is the size of congestion window, threshold and these things, but here you just need to have it, with the basic foundation, in the sense that what is happening with the window. Once you understand what is happening with the window, this question is very straightforward. Okay, draw the window to solve this question and then this question is done. Okay, I strongly suggest you to draw the window, right? So if you draw this window, then this question is done. Now you know that okay, 5, 6, 7 has been sent. Now if the congestion window is 1, you will be sending 4. Now 4 is sent, right? Now it will say that okay, now since receiver has already received 5, 6, 7, it will say okay, give me 8. Now the congestion window is 2, and then you will be sending 8, 9. Okay, now you will be sending 8, 9. This is important. And then obviously the congestion window is 3, and then it will be asking 9 10. Obviously you don't have 10 to send, so you will just sending 9. Okay, you will be just sending 9. So this is one scenario. Now let's just see another scenario also. Okay, and then you will understand this question nicely. See, in another scenario there was a doubt of many people. Okay, so you will get to understand. By the way, this question has been taken from some standard university. It was this question is a variation or simplified version of this question that is given here. Okay, I mean I made it little simpler. Okay, whatever was given at that particular university. So basically, the aim of this question is to let you understand that what is happening with the window. Now see here. You will be sending one, right? Initially congestion window is 1. I mean everything till this point everything is fine, right? I mean you will be sending 4 5 6 7, and then this is lost and 4 4 4 has been received. Now on the 3 duplicate AC case, okay, congestion window is increased by 1 in the version 2, and pseudo star threshold is anyway half of this, right? Congestion window. So congestion window is increased by 1. It is not set to 1. Now you just see the window, okay, and then you will get to understand this very clearly. So 4 5 6 7 8 9, you have these this data. I mean 1 2 3 also you have, but I'm not drawing it. Okay, so you see here that this 4 is lost, 5 6 7 has been received. Congestion window at this particular point in time, congestion window was 4. Okay, now you have congestion window 5. So you will say that, okay, this is my congestion window, this is my current window. Is this okay to everyone that this is the current window? Okay, current window. Okay, now you say that, okay, you have 5 window. Can you send 9? See, some people are arguing or some people are confused, which is a valid confusion. Okay, and the question is making sure that you should be having those concepts very clear here. Okay, so just tell me that, can you send 9? This is very important question. At this particular point in time, can you slide the window and can you just say, okay, arbitrarily, I mean, can you send 9? See, this is very important to understand that you cannot send 9 at this particular point in time. At this point in time, okay, even though congestion window is 5, okay, some people are saying, why we are not sending 9 also? Okay, let's just send 9. No, you can't just send. You have to follow the protocol, right? The window is currently on this. Windows 5, 4 is not sent. So you can only accommodate 8. You cannot accommodate 9. Right? So 4 and 8 will be sent. And then once these are acknowledged, then you will be having the congestion window as 6. So anyway, it will be 9, 10, 11, but you don't have more data. So till 9 only you have the data. So you will be sending 9, right? Is this understood to everyone? Let me know. Okay, see, this was very important to understand here, that you cannot send 9 at this particular point in time. Okay, so cannot send 9. Okay, I hope you understood. Let me know if there is any doubt in this particular question. Right, so so basically whatever is the answer, in version 1 we are sending packet 4. I think A and B are the answers, right? Yes, in version 1 we are sending the packet 4. In version 2 we are sending packet 4 and 8. So this was, I will rate this question very nice. Okay, it is just hitting the concept. Okay, even see, don't worry if you don't know the concept, because we are learning. Okay, we have just got to learn a concept where we can apply the window along with, okay, apply window along with this congestion. I mean these congestion protocols things, right? Okay, along with all of the slow start, turn, congestion avoidance, along with, just if you learn to apply the window, then you can solve this question very easily. Okay, so with this question we learn new thing. What we are learning, we are learning to apply the window also. Okay, that is why this question is beautiful. Understood? Okay, now let's just solve the next question. Okay, so this question is little calculation based, right? So yeah, if you know the CRC, then you should be able to do this question directly. It is basically saying that you have your polynomial as this, and your data is this, and you want to encode using the CRC, right? So you can represent this also in the binary form. So 1 means 2 power 0. Okay, so 2 power 0 is 1, 2 power 1 is 1, and then 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Okay, so this is basically the binary representation of this 1 0 1 1, and I think someone has answered. So you can basically just do this computation, right? So this easy question, I guess. Okay, So basically, if you divide it, I mean, this is a CRC question, a standard CRC question. By the way, this question has been asked in GATE, do you know? And interestingly, not in GATE CS. So maybe I can just tell you. Yeah, this question has been asked. I've taken this question from GATE ECE. Okay, so this is recent. Okay, this is recent GATE ECE question. I've taken this from ECE. Okay, just I was just taking it because it seems a good, well-framed question. So it is GATE ECE 2024 question. Okay, okay. By the way, this is GATE ECE 2024 question, right? Recent question. But yeah, that was a simple question. I mean, as a CSE student, also we were able to do it, right? Yes, congestion window will not slide in that particular question. Okay, now let's solve this question. What they're saying, that B is linearly independent set of vectors for what value of H, right? So basically, you know that for to solve this question, if you want the linearly independent vectors, right, then you want the determinant to be non-zero. So if you find the determinant, right, and then you know that okay, for determinant is this, then you want H to be not -1. If H is not -1, then D is the correct answer, right? Okay, so you want that okay, all of these three should be linearly independent. So you want the determinant to be non-zero, so that all of these are linearly independent, right? If the determinant is zero, then columns are linearly dependent. If the determinant is non-zero, then columns are linearly independent, right? Okay, so this is easy question, I guess, right? Let me know if there is any doubt in this question. Okay, now let's solve this question. This question was also kind of straightforward, but little bit attention might be needed here. So you have n equal to 4 and s equal to -4, right, to start with. Now you are saying n equal to n minus s and s equal to s plus n. So maybe I have this. So n equal to 4. Let me just copy this particular code here. Okay. So n equal to 4, right, and s equal to -n. Now n equal to n minus s. Okay, n equal to n minus s means n equal to n is 4, s is -4. So basically it will be 2n, which is 8. S equal to s plus n, right? So s equal to s is actually -4 plus n, it will be again 4. So now if you do s plus plus is 5, 7, and then if you do run it one more time, then it will be n equal to n is 7, 7 and s is 5. So 7 minus 5 it is 2, and then 5 plus 2 it is 7, something like this, right? I mean, if you want, you can find the pattern, but you can since it is 1 or 2 iterations, you can directly solve like this, right? And s is 8. Okay, so 8 is the correct answer here. Is this okay to everyone? Let me know. Okay, this was a good question. I mean, Gate actually asks these kind of questions, right? I mean, they sometimes ask you to just solve these. They Gate generally ask. I mean, sometimes they ask you to run through the loops or something like this in C programming, right? Sometimes they do it. So that is the reason, like we are doing it also, right? Sometimes they ask you to run through like this, right? Run through the loops and all. Okay. Now let's just move to the next question. Yeah, that was a lengthy question, to be honest. Okay, that was a lengthy question because sometimes the Gate also does it. So we are basically putting the questions which are mixed kind of questions. Some questions are straightforward, some questions are lengthy, some questions are having the conceptual strength, some questions are very easy, something like this, right? Because Gate is, see, since last 2 years. Okay, to be honest, since last 2023, 2024, Gate has been very kind to you. Okay, so I'm not saying that it was very. What I mean to say, it doesn't mean that it was very easy to get top rank in Gate. Okay, in those 2 years, but honestly, Gate has been very kind to you guys. Okay, for these 2 years, but it won't be the case. It necessarily need not be the case. You just see Gate 2021. Okay, Gate 2021. To be honest, you will feel that Go classes test series is far easier. Okay, it's easier than Gate 2021. Once you see this paper, see, people are saying that okay, why so many tricky or good questions are there in go classes test series. See, just because of 2 years you can't say that okay, for the next year it will be very kind to you. You should be knowing the concepts, right? So you should be having the good conceptual knowledge. You can't rely on the easy paper. See, you can't just say that if paper is easy, then I will top. If paper is not easy, then I will try next year. Is this the way you are going to prepare? No, right? So see, with the test series, don't get afraid with the question. Just learn from the test series, because anyway, this is a learning phase. You have to learn till 31st of January. You should be learning till 31st of January, in the sense that there is no examination, there is no real examination. Real examination will be on the 1st February only. Okay, you will be learning till 31st of January. No, gate 23 and 24 both were kind. Okay, you just see earlier papers. See, nowadays toppers are getting 90 plus marks or something like this, right? You just see the earlier things. Earlier 85 plus was huge thing, right? I mean, nowadays 80 plus are many toppers, right? Earlier 80 plus were just 10 20. Nowadays 85 plus are many toppers. I mean, maybe 30 40, right? So it has been easy. Just see earlier papers, you will get to realize it. Okay, so what I'm saying here is that okay, this question was lengthy, so let's just solve this question. What they're saying that we toss two fair coins simultaneously and independently. If the outcome of two coins has been same, then we win, otherwise we lose. Let A be the event that first coin had, B be the event the second coin had, right? And E be the event that we win. And then which of the following is or are true? Okay, this was MSQ question, but I think only one of the option was correct, right? Okay, so let me paste this options also. So A be the event, as it is saying, A be the event where first is had, B is the event the second is had, C is the event that we are winning, and we are winning only when both are same. So since we are tossing two coins, so basically this is the sample space, right? So I'm just writing what is the A, what is B, what is C. I hope that is clear to everyone. Now, since these are just elements in on ABC, so that's why probability of A, B, and C are 1 by 2, 1 by 2, 1 by 2 only, right? Now, event A and B are not independent. This is the first option. So A is the event where first is had. B is the event where first is had. Obviously, it is very clear. I mean, this is very intuitive that it is true. Oh, sorry, it is false, because they are actually independent, right? They are actually independent. Now, the second option is that A and C are independent. Okay, the second option is that A and C are independent. This is the second option. A was the first is had, and B and C was we win. Right? Are they independent? What do you think? So let's just see this. Let's just see this first mathematically, and then we can see this intuitively also, right? So what they're saying, let's just see this option B mathematically. A and C are independent if that is the case, isn't it? So if you calculate, so you can just you have your sample space with you. You can quickly calculate A intersection C is basically HH. So it is 1 by 4. Probability of A into probability of C is also 1 by 4. So 1 by 4 and 1 by 4 are equal. So that is why it is true, right? That is why it is true. What is the intuition behind it? Why that is true? What do you think? See, A is basically saying getting head, right? I mean, you are getting head or you will win. This is independent because I mean, see, first of all, don't apply the intuition, because intuitions are basically not very strong here. You should go with the mathematics, right? But A and C are independent. Why? Because A is getting head. Now you will win or lose. Basically, I mean, you get head at the first place or tail at the first place doesn't tell you whether you are going to win or lose, right? Combinedly, whether you're getting head or head tail, something like this, that will tell you are going to win or lose. So just getting head doesn't tell anything whether you are going to win or lose, right? So by the way, but do mathematically, because it is easier and it is strong. It is for sure 100% proof is that it will be correct. Now let's just see the option C, where we are saying A and B are conditionally independent given C, right? So C, which means this will be true if this is happening, right? A and B are conditionally independent given C. Now you can just find out A given C, B given C, right? So so if you find out A given C, B given C, you can find out these probabilities, and then you will see that okay, these two are actually not equal, right? I mean, this is coming out to be 1 by 2, this is coming out to be 1 by 4, so these two are actually not equal, so this is false, right? So what they're saying that A and B are conditionally independent given C, which means given that you have won, okay, given you have won, you won, then whatever the first head is doing, whatever the second head is doing, are they independent? No, they have to be same, right? I mean, intuitively you can say they are not independent given that you have won or given that you have lost, right? See, A or A complement doesn't matter, right? I mean, basically you are saying that okay, given that you have won, whatever first head is doing, okay, at first head, at first toss, whatever first toss is doing, whatever the second toss is doing, they should be same, right? They're not independent now given that you have already won, right? So intuitively you can say that okay, this is false basically, right? Probability of winning is 3 by 4. Probability of winning means C, that we have already calculated, this is 1, so this is also false. Okay, so that is why only B is the correct answer here. This was little lengthy. Okay, but yeah, that was interesting, and sometimes get asked these lengthy questions also. Actually, initially, to be honest, I was thinking to just put only one of this. I mean, I was thinking that okay, I will just ask these things. Okay, I will just asking probability of A, probability of B, probability of C. Okay, I will just asking this, and I was thinking to just club these two things. Okay, I will be. I mean, I was not thinking to give B and C as options. I mean, I was thinking that I will give A as option, one of the option, D as one of the option. Similarly, that okay, probability of A is 1 by 2, something like this. Probability of C is 1 by 2. I was thinking to put these kind of options. Okay, but then I thought okay, maybe I can do some lengthy question for this particular question. Okay, probably because calculus question I made it easy. Okay, so there was one calculus question. Okay, so I think I've not copied that question, but yeah, there was one calculus question, right? So that limit question, do you remember that question? Maybe I can just quickly copy that question. Okay, so actually that particular question I made it easy, so I thought that okay, we can make one question little lengthy, because ultimately I have to balance engineering mathematics, right? So that is the reason. Okay. So this question was actually easy one, and that was 2 mark question. That is the reason I actually made the probability question little lengthier one. Okay. But yeah, for these kind of questions, I will suggest you to not do intuitively if the intuition is not very strong. Okay, try to do it with the sample space. Okay, try to do it with the sample space. You will be able to solve easily. Now for this question, you can take, I think these are standard questions, so you can take x6 common here. It will be 4 minus x upon x6 square root, and then x cube, and then you can take x cube common here. It will be 1 plus 8 upon x cube, right? X cube will get cancelled out since x is infinity, so this is 1 upon x power 5, this will be 0, this will be square root of 4, this will be 0, this will be 1 plus 0, this is 2, right? 2 upon 1, this is 2. So this is easy question, so 2 is answer. Is this okay to everyone? Okay, now let's see this question actually, one of the nice question I can say. Interestingly, like I made this question from Washington University, and they were not asking directly the same thing, but they were asking something else, and then somehow this question clicked to me, and then I asked this question was from Washington University, and then I was asking on the gate or flow. Okay, then how many of you like this question? So many people, okay, many people upvoted, right? One of the best question, they are saying too good, like this, right? Many people upvoted. Maybe I can just put the screenshot. So see, for this particular question, I was just asking how many of you like this question. So that particular basically comment has got many upvotes. So getting, you know 35 upvotes on a comment in just I can say in just 4 days is a very good number. Okay, so many people actually like this question, and this question was easy, nice question, one of the very different question, in the sense that gate has never asked this question, but it was doable question. Okay, gate has never asked this kind of probability questions, right? But it was doable question only. So let's just see this question. What this question is saying? This is saying that you have cache memory, right? In the cache memory, you can store as you can see, okay, you can store this is a direct map cache, single level, 256 bytes, and which is 2 power 8, and integer size is 2 power 2. Basically it is 2 power 6 elements, right? You can store 2 power 6 integers, right? So you can store 64 integers, so a0 to a63. I mean, if you want, you can store 60, basically 64 integers you can store here. Now they are saying that if you are basically you are getting hit on, the probability of hit on a1 and a2 after missing on a0, okay, because cache is initially empty, so anyway you will be missing on a0. So this is main memory, right? Here a0 and everything is stored. Now you will be, this is a one block size, okay, this is one block size. You will be basically bringing the whole array, because a0 was missed, so you will be bringing the whole array of one whole block. Now if you're storing this a0, you have options to store the a0. If you can store a0 here, you can store a0 here, you can store a0 here in one block, right? Something like this, right? So if you store a0 here, then you can store the whole array. So basically that's what this question is saying, that we have array of integers that is stored in the integer align address, which means you have to store either here, okay, you have to store array here. You can't start the storing from the byte number 2 or something like this, right? That is given in the question. Anyway, that is a basic practice, okay. I mean, in practical scenario also we does this, okay. We also store like this in the practical scenario. Cache is single level direct map. Block size is this. Assume this. If the sequential access is performed, the probability of getting hit on this after initial cache miss on A0. Okay, this is the question. Right. So this is very good question, right? See, if you are storing A0 here, then obviously A1 here, A2 here, then you will be hitting on A1 and A2 also, okay? Because that will be in the same block. But if you are storing A0 here, then A1 will not be stored, right? A2 will not be stored like this, right? So basically, if you're storing A0 here, then only A1 and A2 will not be stored. And if you're storing A0 here, then A1 will be stored and A2 will not be stored. So basically you store here or you store here. At these two places, if you store A0, then only there is a problem. I mean, you will be missing, right? Probability of getting hit, cache hit. Okay, they're asking the hit only, but you will be missing if you store here. Otherwise remaining 62 position are good for you out of 64, right? So basically 31 divided by 32. So this is the answer. This is the answer. This was really a nice question. Okay. So this AIMT has been nice, to be honest. This was little lengthy. Okay, we will be making sure that the next AIMT will not be that lengthy. Okay, so the next AIMT will be AIMT 3. Okay, so this is going to be on the 5th January, as you know. Let us just know that what kind of AIMT you want. Okay, what kind of AIMT you are looking for. Okay, we are planning to make this AIMT less lengthy, okay, less lengthy, and more you can say cute questions. I mean, short and cute. Okay, more short questions, right? It will be easier one. We are thinking to make this AIMT easier one. Let us just know that what is your thought. Okay, so you can just let us know in the comments. See, we are going to make AIMT 3 in just, I mean, we are going to start AIMT 3 in just 3-4 hours, you can say. I mean, today we will start making AIMT 3. So you can just let us know what kind of AIMT you are looking for, and we will do that kind of AIMT only. Okay, in the comments you just let us know. Okay. Yes, it will be similar to gate. I mean, it will definitely be similar to gate. Okay, AIMT 1 was perfect. Okay, so you can just let us know in later on in the comments, right? So thank you everyone. I hope you have really liked the solutions. If you're liking the solutions, if you're liking the efforts that we are making in, then I just request you one thing. You can just put a comment, okay? Because each of your comment is very, very motivating to us. Okay, if you put a comment, it really motivates us a lot. Okay, so see, one comment actually energizes us a lot. Okay, yes, there might be a negative comment, and then we will improve on that. Okay, if you have something to suggest, if you have some critics, that is also welcome. But if you have really like the questions, if you have really, like the solutions, if you have really improved using this AIMT, then just let us know in the comments. Okay. So thank you everyone. Take care.